All right, CNT125, Chapter 11, we're working on the section on managing our network traffic. After we have our, kind of like our network management up and system up and running, we then want to start managing our traffic with, with the baseline, gathering statistics, all that stuff. Then we actually might want to start tweaking the network for having certain types of traffic get through with limited delay, that sort of thing. So that gets us into the performance management. We also want to look at when we do have an issue, knowing when that occurs so that we can respond to it. So those are two big factors when dealing with managing our network traffic. Make sure things are performing as they should to let voice and video through first and not get delayed, and then also knowing when we do have problems in the network, what they are and how to respond to them, whether it be a component failure, link failure, whatever it happens to be. So those are two big aspects of, once things are up and running, managing our network. All right, so that brings us to traffic shaping. When you have high volumes of network traffic, you might need to set some criteria on this type of traffic can be delayed, this type of traffic cannot. This is called traffic shaping. When you're manipulating the packet data stream, etc., to the traffic that's moving across the network. And again, your goal of doing this is really making sure the most important traffic gets there and it's not delayed. The other stuff is going to get there, but hey, your file download might take a couple of seconds longer to make sure this phone call does not have jitter or excessive delay to it. So there's different techniques. You delay less important traffic, like I just said. You might let the YouTube stream that somebody's doing in their lunch hour have less priority than the voice over IP phone traffic that somebody's doing. Or I can increase the priority of more important traffic. Again, I might put my IP phone traffic as a higher priority. Everything else goes lower. So keep that phone call going. Everything else just kind of fits in around it. This is all basically traffic policing, limiting the traffic flow in and out of a certain interface at a certain period of time, or limit the momentary throughput rate for an interface. And that's all in the name of trying to make sure that our most important traffic is getting through first. Just as a side note, the book talks about a controversy with Comcast that happened a number of years ago. They actually spell it out for you, but it boils down to back in the days when you had kind of like unlimited network bandwidth, as people were doing things like streaming things or BitTorrenting and that sort of stuff. The neighbors in the neighborhood were complaining because their bandwidth was dropping. So Comcast responded with watching all the traffic moving through, doing deep packet inspection, looking for traffic like, somebody doing a BitTorrent, and delaying that in favor of the other neighbor's traffic coming through first. While people like us, nerds like us, were doing Wireshark and seeing packets dropped and resets and resends and going, hey, what's going on? And started questioning about it. And that case actually got up to the whole FCC and had a hearing on it. And the judgment from that was, hey, Comcast, you can't be doing that. So over the years, you might have noticed different criteria on your connection if you had Comcast. That's the result of that. That's the result of that over time. So traffic prioritization, treating more important traffic preferentially. Yep. And you might do it based on protocol, IP, coming from a certain subnet, going to a certain subnet, diff serve field, which we're going to get to in a second. That's an actual flag in an IP packet. VLAN tag, again, it might be coming from a specific VLAN, so that's going to get priority because that's, your IP phone traffic, whatever happens to be, particular type of application. Maybe it is your soft phones that are running, okay? So all this can be set that, hey, it's a high priority or normal or low priority. So you might actually have things like your IP phone call set high priority, other stuff normal or low, making sure that your phone call traffic gets through, especially if it's something dealing with sales or your company's based around sales and phone calls. Quality assurance is basically this gist. Making sure that we don't have breaks in a phone conversation or see buffering on a video conference or that sort of thing. So they remind us that voice and video are delay sensitive, meaning it does not take much for delay on a network or a congestion on a network to cause a phone call to get choppy or a video stream to get choppy. We've all seen that. Or a video stream to go and then buffer, then go and then get buffer. So you want to make sure that that your quality of service and your priority on your network is handling things well so that you don't have that happening. Occasional loss of data, skipping of video frames, whatever, can be tolerated. Not really a huge deal. They are what they call loss tolerant, but you don't want to rely on that. You want to make sure that that traffic is getting some priority over other stuff. Your network bandwidth, web serving may not present much of a challenge, but your voice video streams, that sort of thing could become a challenge, putting a lot of demand on your network resources. So it might benefit from putting some quality of service in that this gets priority, then this gets next, and this gets next, making sure that those things they're allocated what they need. So quality of service, we're going to make sure that a certain type of traffic, a certain type of protocol, that sort of thing, is going to get priority over other stuff. And there's two different techniques of doing that. Looking at the diffserv field and setting things based on your diffserv flag in your IP packets, or setting a class of service, one of the two. So diffserv, there is in the IP, the layer 3 header, there is a diffserv field in the IP header that can get used. Different types of traffic set that value, and things like your routers and interfaces and that sort of thing could be reading that and referencing that, saying, oh, this is more important, let this go first, this is less important, let this go second. And that is, if you look at your IP header, source IP, all that good stuff, source IP address, destination IP, but if you look at some of the first couple fields, there is actually a diffserv field. So traffic moving through the network sets that flag in there, and that's something that can be read and used to make sure this traffic goes first, this goes second, etc. And that can be done by doing something like an access list on an interface or device and reading that field and reading the differentiated services code point value in that header, that diffserv field in that header. So we could do an access list to read that, match it, and do something with it. That would be a way to handle some quality of service using that diffserv field. And you can do different types of forwarding, expedited forwarding or assured forwarding, based on that criteria. If I see that in there, I can say, okay, we'll make sure this gets done or this gets done. In your expedited forwarding, data stream is assigned a minimum departure rate, circumvents delays, slows normal data from reaching its destination on time and in sequence. And your assured forwarding, well, if you take a look, here's a chart that kind of helps. This is actually a chart showing your this value, the DSCP value in binary, and a name for it. And when you look at things like your expedited forwarding, your voice, your telephony gets that sort of rating. So if you're going to do some quality of service based on diffserv, you would set based on that value. So I would do something like access this one, I permit IP any, DSCP, EF, and then go on and maybe do some other denies, etc. On that. So if I were to take a look at, and I think I have that in our packet tracer here, if I go to my switch here, I believe I have plugged that in. So let's do a show run. And down here on the bottom, I think I have a little, here we go, access this 101, permit IP any, DSCP field, EF, this is your expedient forwarding. So if we see in that in there, then I would write more rules to say, well, then do this with it or do that with it. And that's setting that, allowing that traffic through. I might put other stuff and deny other stuff or limit other stuff based on that value as well. So there's one way to handle some quality of service. The other one is with class of service. Class of service basically is, okay, this is kind of a layer 2 thing. So now with class of service, I can say, okay, well, this type of frame of data is going to get this processing, if you will. So if I take a look, when we deal with your Ethernet frame, there is a tag in here, and there is actually the PCP field, priority code point field, that is in there and can be read at layer 2 to know, to the switches know, hey, this goes first, this goes second, or this gets handled this way, this gets handled this way. So if I look at, here's my class of service value, you saw it was value of 0 to 8, if you will, or 0 to 7, because of the bit field, 3-bit field. If I have a value, a class of service value of 5, that is basically indicating a DSCP value of 46, which is going to give you a class of service where your voice over IP traffic is processed priority above other things. So what I can do on a device like my switch, say, okay, for these interfaces that might have IP phone on, please have them priority class of service 5. So if I look at, again, I'm going to go over here to my switch, and I look at my routing config. I put a handful of ports here, ports 10 to 15, in I gave them a class of service of 5, switch port priority extended class of service 5, indicating, hey, there's IP phones on here. These are going to get a higher class of service than the other ports on this switch. So that'd be another way to handle some priority dealing with, in this case, IP phone. Okay, so I'm going to hold on there. We'll come back in the next one and start talking availability.